You're listening to the N2K Space Network.
How many discounts does USAA Auto Insurance offer? Too many to say here. Multi-vehicle discount, safe driver discount, new vehicle discount, storage discount, legacy.
How many discounts will you stack up? Visit USAA.com/auto discounts. Restrictions apply.
The Axiom 4 mission, or AX4 mission, will realize the return to human spaceflight for India, Poland, and Hungary, with each nation's first government-sponsored flight in more than 40 years. And while AX4 marks these countries' second human spaceflight mission in history, it will be the first time that all three nations will execute a mission on board the International Space Station. So, what are they going to be working on during their time in the orbiting lab? Let's find out. Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. Joining the AX4 crew are around 60 scientific studies and activities representing 31 countries, including the United States, India, Poland, Hungary, Saudi Arabia, Brazil, Nigeria, the UAE, and nations across Europe. This will be the most research and science-related activities conducted on an Axiom space mission aboard the International Space Station to date. And to learn more about all of this, I speak with Axiom's chief scientist, Dr. Lucy Lowe, to find out more about the science experiments that will be heading to the ISS with the AX4 mission.
I'm chief scientist at Axiom Space, and I started out as a neuroscientist. I was training in the UK. I did my undergraduate and my master's and my PhD in the UK in neuroscience, and I wanted a lab. And so I was lucky enough to get the opportunity to go to Canada to do a fellowship in neuroscience. And then I was lucky enough again to be able to come down to the US National Institutes of Health to do neuroscience research. I was doing research on the neuroscience of pain, and it was absolutely fascinating. And I thought I wanted my own lab. And it's really tricky for graduates and postdocs to get into academia. It's there are not many positions. It can be very difficult to find funding. And so I was kind of struggling along even at NIH. And then I realized that what I always loved anyway was the big picture science. It's talking about the opportunities of science, explaining why science is awesome, and also helping other scientists do the research that they wanted to do. So what I did is I transitioned into program management and science administration, essentially, at NIH. And through that, I was lucky enough to get the opportunity to manage a bioengineering research program that was taking place on Earth, but it also had part of that program actually taking place on the International Space Station. And I hadn't paid too much attention to space before then. I thought it was cool. But through that work, I realized what an incredible environment the microgravity environment offers for research, for science, for understanding how cells interact, how molecules can talk to each other, how materials might be produced or manufactured in a different way. And I thought, wow, this is amazing. And so I was lucky enough to be able to get to know lots and lots of people across the space industry, across NASA, and across various different government agencies as we worked towards pulling together lots of government officials to try and really take advantage of some of the opportunities of microgravity for things that NASA might not be doing that might fall outside of kind of NASA's mandate. And then it was a really exciting time at the early 2020s to be looking at the space industry and looking at these companies that were starting to build space stations and looking at how we're going to transition from a government-funded to a commercially funded infrastructure and ecosystem, if you like, in space. And I thought, wow, this is a really fun time to be doing this and a really interesting challenge to be looking at how do we move from government to commercial support for research in space. And I thought, well, I've done academia and I've done government, so maybe it's time to give industry a go. And I was lucky enough to join Axiom Space about 3 years ago. So I've been having an inordinate amount of fun learning all about the different kinds of research that can take place in space and all the incredible research that's been done there over the last 50, 60 years. And it's just a tremendously exciting time to be figuring out, okay, how do we continue to support that important fundamental research, applied research, technology demonstration development? How do we continue to support that and expand that and develop that as we go through this fundamental transition from NASA-sponsored, ESA-sponsored, JAXA-sponsored to an independent private commercial company or multiple, hopefully, commercial companies providing the infrastructure? It's been a fun ride so far.
That is a fascinating journey. And I love learning about how people end up where they end up, because it's often we don't start out thinking, oh, I'm going to go into the space industry or even if there's any interest in space. And then sometimes it just happens. And I think your incredible scientific background leading you here is just a wonderful thing. So thank you for that. As of the time of this recording, the AX4 mission has not gone yet, but it will be soon. So that is sort of what brings us together today for us to talk about a bit, because the next question that comes to mind for me is, how does one prioritize? I'm sure that there are so many options for the science that could go up on this mission. How do you choose?
Yeah, so that's a great question about how we prioritize the research that flies on a mission. So our next mission is the most jam-packed mission that we've flown to date. It is chock-a-block, full of really interesting and exciting and some really quite groundbreaking research from all kinds of areas of science. And so the prioritization that we do is based on a few different metrics. So the first one is we work with the customers to find out what is the highest priority for them. So when we're working with international customers, we're working with India, we're working with Poland, and ESA, we're working with Hungary on this next mission. We need to understand from them what is their highest priority research that they really want to get done during this mission. Because regardless of anything else that happens, sometimes crew run out of time, or if something happens on orbit or there's an emergency drill, then the crew might not have time to do the research. So we need to be able to adapt in real time and make sure that we can get the highest priority research done for the team. So we always want to know what their priorities are. The next metric that we have to look at is it feasible? And there's a number of different variables that kind of feed into what is the feasibility of a space research project. The first one is it technically feasible? If it needs hardware, is it going to be developed in time for flight? If it's human subjects research, it needs to go through a process where it goes through independent review board or IRB approval so that it's ethically approved and it's safe for the crew to take part in, for example, and that they can consent to. If there is particular reagents flying or particular materials flying, are they safe to fly on board the ISS? There are very strict rules and regulations about what can and can't fly because of various flammability or some of the gases that it might emit or off-gas. And so all of those need to be assessed very carefully. And those are assessed by Axiom and also by NASA, because we are using NASA's assets. So we're, not only relying on them, but tremendously grateful for all the work they do to help accommodate our research. But they have to approve and review everything that we do. They also have to check if it's feasible in terms of if there is software that needs to be used or integrated into the ISS systems. If that's going to be sent up there, is it clean software? Is there a bug in there? Is there a virus in there? So obviously the last thing you want is that getting onto the ISS. So there are a lot of reviews and approvals and certifications that take place that check whether or not a project is feasible to fly. Feasibility also includes things like, is there physical space for it to fly on a Dragon capsule with crew? Is there physical space for it to get plugged in if it needs to get plugged into a rack, if it needs power supply or a data downlink? Can it fit actually within the complement of the physical space, the volume that we have for transport, both on the way up and on the way back down? And then there's the feasibility of, does the crew have time to do it? So is there a very labor-intensive project that requires 4 full days of a crew member's time, then do they have that time available? Because they have a lot to do. And they're very, very busy while we're up there. And they might also have mission-specific things they have to do for their country that they're representing, which might include, STEM and outreach activities, or talking to an ambassador or a political person. And so, their crew time is very, very busy. And so all of that means that we have to coordinate very carefully with our customers, with all of the teams that are working on the hardware and the integration aspects and the operational aspects of a payload, as well as the researchers themselves. And we have to make sure that all of those are in agreement, that everything is safe and will get ready to fly in time, that the crew has time to do it, that they've been consented to do it if it's for human subjects research. And then we have to figure out, okay, well, where does a payload sit on the priority list for our customers? And then that's not just our customers that have priorities. Axiom has payloads that we fly with our research partners as well that we also need to get done. So there are so many moving pieces that goes into what ends up making the mission research portfolio that in itself could be a couple of hours long conversation. So I'll stop there and see if you've got follow-up questions from Matt, because that was a lot of information.
It is. I'm fascinated by that, and I'm going to be saying that word a lot in our discussion, just because this is genuinely really fascinating to me. All those variables to keep track of. I'm a little overwhelmed just hearing it. So massive respect to you and your team. And the other thing that strikes me, you also mentioned, I think the paradigm in my head was sort of, once this is all decided, it's good to go, you're set, it's set in stone, so to speak. But you mentioned that, things do change once you get there. Sometimes there's something, not in a bad way necessarily, but something needs to change for some reason. So that must involve an unbelievable amount of just being prepared for some backup options.
You're exactly right. So we have awesome teams here at Axiom Space. And like I said, we're super grateful to NASA, to the ISS National Lab, to all of the partners and the customers, and it really does take probably thousands of people to get these projects to space. So it really is a team effort. But fundamentally, what we have at Axiom is an incredible team of operational specialists who understand exactly how things need to work within a space environment and within a mission timeline, because those can be very challenging. We have, we have a lot, we don't have as long as NASA crew do for a research increment, for example. We have a couple of weeks, and so there's a lot to squeeze into that time. But we also have an incredible team of research integrators. We have an incredible team of ground support staff and mission control staff who are able to work in real time with NASA, with the rest of the ISS flight controllers, for example, and with the crew and with our customers. So it is an extraordinarily complicated endeavor, and it does require, as you picked up on, incredible flexibility. So it sort of speaks to the expertise of every single person involved that we're able to pull these off, frankly. It's hard. It's really hard. We've flown 3 successful missions to date, and we're super excited about the 4th. I know our crew is raring and ready to go, but the levels of preparation that it takes to get to this point, where, like you said, then you have to be ready to pivot to plan A, B, C, D, all the way through to plan Z, is just extraordinary.
We will be right back.
Hey everybody, Dave here. I've talked about Delete Me before, and I'm still using it because it still works. It's been a few months now, and I'm just as impressed today as I was when I signed up. Delete Me keeps finding and removing my personal information from data broker sites, and they keep me updated with detailed reports, so I know exactly what's been taken down. I'm genuinely relieved knowing my privacy isn't something I have to worry about every day. The Delete Me team handles everything. It's the set it and forget it peace of mind. And it's not just for individuals. Delete Me also offers solutions for businesses, helping companies protect their employees' personal information and reduce exposure to social engineering and phishing threats. And right now, our listeners get a special deal, 20% off your Delete Me plan. Just go to joindeleteme.com/N2K and use promo code N2K at checkout. That's joindeleteme.com/N2K, code N2K.
As a contractor, I don't pay for materials I don't use. So why would I pay for stuff I don't need in my mobile plan? That's why the new MyBiz plan from Verizon Business is so perfect. Now I can choose exactly what I want, and I only pay for what I need.
Right now, with MyBiz plan, get our best price, as low as $25 a line. Visit verizon.com/business to get started today. Price per month with 5+ lines. Includes autopay and paper-free billing and special intro offer discounts. Taxes, fees, economic adjustment charge, and terms apply. Offers end June 10th, 2025.
Yeah, the space is hard cliche exists for a reason, and sometimes there's really no better way to put it. It's hard. So massive respect. If you don't mind indulging me, if we could start talking a little bit about maybe some of the specific scientific endeavors that are going to be going up on AX4. I know there's so many.
So I'm biased because I'm excited about the Axiom space ones. I'm excited about all the research. I'm not going to lie. I'm a massive space nerd. I'm a massive.
I would hope
so. If we were going to talk about every single one, we'd be here for 3 weeks. But I'm really excited about a couple that we're flying on AX4 specifically that are related to the work that Axiom's doing. One of them is called Sweet Ride, and it is a cheesy pun where it is actually related to how we can validate continuous glucose monitors, insulin pen technology, and the stability of insulin in spaceflight, so that in future, Axiom wants to be able to expand the diversity of crew that can fly in space. So to date, diabetes has been a disqualifying event for a potential astronaut. And Axiom was working on the foundation that we want to make space accessible to every human everywhere. So we not only want to be doing things in space that are for the benefit of people back here on Earth, but we also want to be expanding the opportunities for anyone on Earth to fly in space in future. And that includes flying people with chronic health conditions. So one of the health conditions that we're working towards flying is the management of diabetes. So we've got some really cool research going up on AX4 that is having crew wear continuous glucose monitors to check that the monitoring of blood sugar is uninterrupted in a space environment. There may be physiological changes, for example, that actually impact that. And we don't expect them, but we don't know until we try. We're also looking at how insulin how shelf stable it is, if you like, in space. We don't expect, again, changes, but we need to know that there aren't, so that if we set insulin for crew in future, that it's going to be safe for them to use. And then we also need to know that the pens that might be used to give that insulin give the correct dose in a microgravity environment. All of these things we expect would be unchanged, but they're critical that they're checked so that we know that that would be safe for crew to use in future. So that's just sort of some of the work that we're doing to pave the way for a safe and healthy place for people to work in space in future. So that's one thing.
That is fascinating. That's fascinating. Yeah.
Another project that I talked about the things that we're doing in space for people in space in future, but I talked about the things that we want to do at Axiom that are for benefit of everyone back here on Earth. And one of those is called Cancer in Leo. And it's actually the third iteration of this particular project and the fourth flight for the team that are flying research from the Sanford Stem Cell Institute at UCSD. And they're flying cancer tumor organoids, which are small balls of cancerous cells, essentially. And what they're looking at is how these cells respond differently in microgravity, because they're actually using microgravity as a tool to accelerate the disease formation of cancer and to understand better how cancers form, which is obviously incredibly important. But this team they're through the course of the work that they've done with Axiom, they've actually been able to start testing a drug that they're developing back here on Earth in space. And what they're actually finding is that they're able to accelerate that drug testing timeline by doing it in space because of the accelerated growth of the tumor organoids in space that enables them to test this drug and test some of the effects of this drug in a more efficacious and speedy manner, which is huge when we talk about drug development, because that can take decades on Earth and it can cost billions of dollars. And obviously cancer is not cancer is a massive suite of diseases that we cannot afford to be just, ignoring. So the team are working on a few different cancers, and one of them in particular is triple-negative breast cancer on AX4. So we're really excited about that work as well.
I was really fascinated that ISRO is going to be looking at tardigrades, which everybody loves tardigrades. And part of me was like, I think there's almost infinite amount of things that we could learn about tardigrades. Could you just tell me about that experiment? Because I just feel like tardigrades are a really fun thing to talk about.
I know, no, everyone loves tardigrades for sure. So we're super excited to be flying these. So what I didn't know, and I learned throughout the course of this mission, I knew that they were also called water bears, but what I didn't know is that they're also called moss piglets, which is...
I did not know that.
Adorable. Ridiculously adorable. But anyway, yeah. So tardigrades are incredibly hardy little organisms that are very well known for their amazing resilience in a number of different environmentally extreme conditions, shall we say. And so what is really interesting is that if we can understand more about these genetic and molecular mechanisms of resilience that tardigrades can employ, then maybe we can start employing those to different aspects of human health here on Earth. So if we can understand, for example, that there's a particular genetic pathway or a particular molecular pathway that is employed within a tardigrade cell that allows their cell to become more resistant to spaceflight-associated radiation damage, for example, then that might help us understand, okay, well, maybe when we're talking about cancer therapeutic treatments, I'm just spitballing here, but the ideas of sound is that if we're talking about cancer therapies here on Earth, we talk about radiation therapies. And what the radiation therapies actually do is that they aim to kill off the cancer, but they can also damage other cells. Well, if we can understand some of the molecular mechanisms of resilience, then perhaps we can employ countermeasures for cancer therapies that actually focus on the cancer and not focus on the healthy cells. So there's opportunities to really delve into these, what we call molecular mechanisms of resilience that open up all kinds of new possibilities for therapeutic development, or for potentially even gene editing of organisms back here on Earth that are in very austere environments. As we move towards climate change in certain areas, then maybe there are plants that could become more resilient to drought or more resilient to different kinds of toxins in the soils, for example. So we've kind of barely scratched the surface of what this resiliency might look like. And so because tardigrades are such a cool little organism that just have this unprecedented resilience, it just offers an incredible opportunity to explore. And so because spaceflight is an environmental stressor, it is likely to activate those pathways of resilience. So this project is looking at the revival, survival, and reproduction of tardigrades. So they're looking at different aspects of tardigrade life cycle, essentially, and how those resilience mechanisms might be applied across that life cycle. So that gives them lots of potential different targets to be investigating when it comes to those genetic and molecular mechanisms of resilience.
Wow. So in this case, the resilience is I often think of these different experiments as being more microgravity related. This one sounds like it's more radiation related, or is it a both or an and?
It's likely to be all kinds of things. So space microgravity is a physiological stressor for cells. It changes how molecules interact in general. It can change gene expression profiles. And that could be related to how fluids are differentially or moved around the body. It could be related to how the body is responding to radiation that is encountered in spaceflight. The low Earth orbit area of where the ISS is fairly well protected from some really damaging radiation, but there is still a higher radiation level up there that might be impacting these organisms. So it's important to understand that microgravity isn't in itself. It is an unusual and physiologically stressful situation. So all organisms adapt to that in their own way, and we're still doing the research to understand what that looks like and what those adaptations are.
You mentioned fluid, and that was going to bring me to the next one I wanted to ask you about, simply because I saw in the description that this specific experiment may help us better understand Saturn's hexagon, which is a favorite phenomenon of mine. So I said, I just want to hear more about Hungary's shear instabilities. Can you tell me about this one?
Yeah, this is a really fun one. So this is where they're looking at fluid dynamics in space by studying the geometry of a ball of water, drop of water about the size of a tennis ball. And what they're doing is they're going to be spinning this tennis ball sized drop of water in space. They've got some a special piece of equipment that they developed to spin this drop of water in space. And so what they're going to be doing is then recording in high def, essentially, how that ball of water is spinning, and it's also seeded with passive tracer particles. So basically, as the ball is spinning, you're able to trace how those different particles on different parts of the surface of that ball are reacting and responding differently. And what's really fun about this one is that the rate of the spin is going to increase over the course of the experiment. So the way that the crew is doing this is actually they're listening to some delightfully remastered Bach. And actually the music actually increases in speed throughout the course of the experiment. And that is actually telling the crew member who's doing it how fast to crank the handle, basically.
That's their metronome.
Water, exactly. So it's a really innovative way to speed up the rate of rotation of this ball of water over the course of the experiment. And what that is then doing is it's helping fluid dynamics researchers on Earth understand how these large bodies of gases and in this case they talk about Saturn as it rotates, how do the different regions, whether it's polar or equatorial, for example, how does the rate of spin affect the fluid dynamics at each of those different areas? So that's what that project's investigating. And that's why it's trying to understand more about some of the planetary physics that we see within our solar system through doing this, fun experiment on the ISS.
Yeah, I when I was going through the list, I said, I don't know how I'm going to pick. So I just picked stuff that was personally very close to my heart. And Saturn's hexagon is definitely one of those things. So I said, I got to hear more about that. So thank you for that. This has been an absolute delight, by the way. So thank you so much for speaking with me. I've learned so much. Is there anything about the upcoming mission or what you do at Axiom, anything at all that, we didn't touch on that you wanted to mention to our audience?
Yeah, I think from my perspective, the thing that I always want to say is that the things that we can do in space to understand how our cells, our molecules, our plants, our animals, our place in the universe, we've really barely begun to scratch the surface in understanding that. And microgravity and research in low Earth orbit and beyond just offers an incredible opportunity and an incredible environment to keep asking those questions. So, at Axiom Space, we're doing all of these fun things, but we're doing them because we fundamentally want to improve life for every human everywhere. And everything that we try and facilitate for the research is to add to that global body of knowledge that we as a species have that tells us these things about ourselves. So, we're really excited to see the research launch. We're really excited about the results that will come down from it and how it will continue to add to that body of knowledge about us and how we survive and how we live and how we can thrive in space in future.
Dr. Lucy Lowe, thank you so much for your time and for speaking with me today. I really appreciate it.
Thank you, Maria. I really enjoyed our chat.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of our podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Ivan. Peter Kilpie is our publisher, and I'm your host, Maria Varmazes. Thanks for listening. We'll see you next time.
And now a word from our sponsor, SpyCloud. Identity is the new battleground, and attackers are exploiting stolen identities to infiltrate your organization. Traditional defenses can't keep up. SpyCloud's holistic identity threat protection helps security teams uncover and automatically remediate hidden exposures across your users, from breaches, malware, and phishing to neutralize identity-based threats like account takeover, fraud, and ransomware. Don't let invisible threats compromise your business. Get your free corporate darknet exposure report at spycloud.com/cyberwire and see what attackers already know. That's spycloud.com/cyberwire.